Hey, welcome back. This is Power of the Programmer. You're on section 4.6. Let's do that again. Hey, welcome back. This is Power of the Programmer, section 4.6. In this section, we'll be covering visualization of data. And by now, we should have gone over CSVs. What are they? Learned a little bit about CSVs and data analysis. Talked a little bit about the big picture. And also process our data to find the average time between sales, as well as find the sales per state per channel. So by now we should have gone to the clean state and did some analysis. So now we are in the presentation state where if you're working by yourself, having data and understanding data is nice, but sometimes you want to show that data to somebody else to gather insights. And this is where the decision making really comes into play. If you're working in a larger company, if you're to present information to decision makers, a lot of times you have to create presentations. If you're an entrepreneur, sometimes you have to pitch to investors, and understanding the data takes time, and that's the time that we spent doing the analysis. But to convey that information to somebody else in a short amount of time, sometimes it's better to present that information or data in a way that is easy to understand, like a picture. So I like to start out with a formal definition of data visualization, and that is the graphical representation of information and data by using visual elements like charts, graphs, and maps. So you probably have seen data visualization as like stuff like line graphs, bar graphs, wheels, pyramids. They're all good ways of conveying information in the form of pictures. So Python has a built-in library called Matplotlib, which is very powerful at doing this. And that is what we're going to be using for the scope of this course. So if you don't already have Matplotlib installed, just go into your terminal, and if you ran the script in the beginning of this course to set up Python, you should have pip already installed. Pip is a Python package manager that is used to manage all your packages, your libraries. Another name for libraries are packages. And pip will install everything for you. One way to check if you have it is just type pip on your computer, and if you get this kind of output, that means that you have it. If you don't have it, installing is very easy. You can run the script in the section 2 learning examples on your Mac or Windows computer, or if you want to install it yourself, you can just Google it, and there are a bunch of guides on how to install it. This is one way to get it, and I'll put the link in the command in the description. So you just have to run sudo sudo curl and the URL, and then use the column the column key, which is a pipe, and type sudo python. And basically what this will do is, another word for curl is download, and it will download the file and then send that output directly to Python to run it. So what this will do it will install pip on your computer, and now if you didn't have it before, you should have it now. So once you have it, you just have to type sudo sudo on a Mac. On Windows, you don't have to do this. And just type sudo pip install matplotlib, and this will install the package for you. So if you're following along, you can go to section 4 visualization, and we will start working from there. So just open it up in Sublime Text or whatever text editors you're using, and if you can see from the file, the code that we picked up where we left off, and we analyzed the sales data, the sample sales data that we got from our online stores, and did some basic data processing to find the sales per state per channel and the average time between sales. There's one difference in this file compared to the previous file. We decided to make a decision and use the seconds from the average of the dates. So instead of returning the seconds for both, we're only returning the seconds for one of those options. So from here, we can go ahead and this is the completed code commented out. We can go ahead and remove that and just start from scratch. So the first thing we need to do is import the library. So the library is called matplotlib.pyplot, and we can give it a nickname or another label or another variable and call it plt. So we can go ahead and just test it out to see if it works. So the first thing we have to do is call the figure call, which basically says let's start a new graph. So plt figure, and then let's plot something simple, 1, 2, 3, 4, and this will plot 1, 2, 3, 4 as a straight line, and then we just type plt.show to show that graph, and we are in the Python section 4 folder on our terminal, and we just run python visualization.py, and you can see that we have a straight line graph counting up to 4 with the x-axis as 0, 1, 2, and 3. Cool. So this is extremely basic, but it shows how easy it is to really use this kind of library to plot data. So now that we have this library set up and we know that it's working, we can go ahead and do some analysis and visualization of our work. So one example I'd like to do in this section is since we already found the average times per sale, we should find the average time between sales for each weekday. So this is very dependent on the data you are actually processing. Data analysis is one of those subjects that's more of an art form rather than a science. It really depends on the data you're looking at and which way you map it that lets you see it in different ways. Like, for example, if we were looking at sales data over the year, it might make more sense to plot it based on the month. If we had several months to look at, if we only had weeks, then it might make more sense to plot as a weekday. In this case, since we only have a couple of weeks, we know that the smallest loop would probably be a weekday, since we know that habits are formed on weekdays. So Monday is always the first day that most of the working world goes to work. Friday is always the beginning of the weekend. So we know that every Monday is going to be very similar to each other, as well as every Friday. So we can go ahead, and since this is a data set for the month of May, we can go ahead and just plot it by the weekday. So like before, the best way to look at this is figure out what the key objective is, the main objective, which is let's figure out the average time between sales on every weekday, and then the key results to get there, or the key steps to get there, would be first, let's split up the average time by day. Then the next one would be, let's find the average per each weekday, and then let's plot it, and then that should get us the results that we need. So now that we have sort of the structure for how to plot this, and we also have the function for finding the average time between sales, this is a good example of showing how you can write something once and then reuse it in a function. So this is a principle that I follow, and is very big in development as well as business. It's do not repeat yourself and don't reinvent the wheel. If somebody else has done it or you've done it and it works, then there's no reason to do it again, because you're wasting energy. It opens up room for error, and it's just not good decision making. So since we already have a function that finds the average time between sales, the best way to approach this would be, how can we process our data to make it work with this function? So we already know right now that our dates are an array that's ordered by the date that we have. So right now, the big issue is that we have every week in a row, but we want to find the average time on day 1, because it's also similar to day 8, which is another Monday. 2 is Tuesday, 3 is Wednesday, 4 is Thursday, 5 is Friday, so on and so forth. So how can we structure our data to make use of this function, but also in a way that makes it easy to run? So since we already have lists, what if we make a list of lists separating our days? So we can put an array of 1, the sales on day 1, and an array of the sales of day 8. And this is just one of the ways you can do this. There's no right answer for this. It's really whatever gets the job done. Can you think of a way of holding all of this information? If you think a dictionary is right, that is correct. That's one way to do it. A dictionary is a great way to hold this data, and since we're going to make it easy on ourselves, and we know a computer starts counting from 0, then we can go ahead and say the keys are going to be the days of the week, and we can just go ahead and make them lists. I'm going to fast forward because this is very repetitive. Almost done. Great, and we're back. So we have all of the days listed out as numbers, as the keys, and the value set is blank list. So now we have to figure out how to get these dates into this array of arrays by the weekday. So right now we can go ahead and print